James Webb has done something we've never seen before. It's found a planet that checks nearly every box for an Earth-like world. Right size, right temperature, right chemistry. On paper, this should be Earth 3. But the data didn't stop at habitability. It revealed an environment so extreme, so hostile, and so unnaturally stable that survival alone shouldn't be possible. And that's where the fear starts. Because a planet that looks this protected usually isn't empty. When the James Webb Space Telescope began sending back its first serious exoplanet data, most people expected incremental progress, better measurements, sharper spectra, a clearer idea of which planets might someday deserve a closer look. That was the safe expectation. What nobody really anticipated was how quickly Webb would start exposing a problem we weren't prepared to think about. Because finding a potentially habitable planet is one thing. Finding one that looks too stable is something else entirely. For decades, our search for Earth-like worlds was based on a checklist mentality: distance from the star, presence of an atmosphere, signs of water vapor, carbon dioxide, maybe methane. If enough boxes were checked, we called it promising and moved on. That framework shaped how telescopes were built and how data was interpreted. It also shaped how optimistic we allowed ourselves to be. James Webb didn't just improve that process, it quietly broke it. Instead of vague hints, Webb delivers atmospheric fingerprints with a level of precision that borders on uncomfortable. It doesn't just tell us what gases might be present, it tells us how those gases interact, how stable they are, and how long they've likely been there. That difference matters because atmospheres are not passive. Left alone, they drift toward chemical equilibrium. Reactive gases destroy each other. Energy balances out. Chaos fades into uniformity. Life disrupts that. On Earth, the reason oxygen remains abundant is not geology or chance. It's biology. Photosynthesis continuously pumps oxygen into the atmosphere faster than chemical reactions can remove it. Methane exists alongside oxygen, even though they should annihilate each other on geological timescales. The only reason they don't is because something keeps replenishing them. That imbalance is one of the strongest biosignatures we know. And when Webb turned its gaze toward certain rocky exoplanets orbiting calm, long-lived stars, it didn't just see imbalance, it saw persistence. Chemical systems that shouldn't survive for billions of years, still intact. Atmospheric layers that appear strangely well-regulated. Thermal profiles that suggest active control rather than random fluctuation. At first, that sounds like good news. Stability is usually what we want. Stable temperatures, stable climates, stable orbits. But nature rarely produces long-term stability without feedback loops, and feedback loops imply processes. Processes imply activity. This is where the narrative starts to shift, not towards science fiction, but towards something more unsettling. The realization that habitability alone doesn't tell us what kind of environment we're looking at. On Earth, life and environment co-evolve through violence, mass extinctions, snowball Earth events, volcanic winters, asteroid impacts. Our biosphere is resilient because it was forged through repeated collapse. Stability, when it appears, is temporary and fragile. Some of the worlds Webb is analyzing don't show that same chaotic history. Their stars are quiet, their orbits are circular and locked, their climates appear unusually consistent over immense timescales, and their atmospheres, instead of drifting toward entropy, seem to resist it. That raises an uncomfortable question we're not used to asking. What if stability isn't natural? To understand why this matters, you have to step back and rethink what a habitable planet actually means. Habitability is often treated as an invitation, as if the universe is dotted with empty houses waiting for occupants. But that framing assumes that life is rare, slow, and passive. James Webb is forcing us to consider the opposite possibility, that life, once it appears, may be extremely good at staying put. And not just staying put, but reshaping its environment in ways that are hostile to newcomers. On Earth, we rarely think of ourselves as invaders, but biologically, that's exactly what we would be on another living world. Our microbes alone would be catastrophic. Our biochemistry would clash with native systems in unpredictable ways. Even our presence would introduce entropy into a finely balanced system. Now imagine a planet where life has had billions of uninterrupted years to optimize survival. Not just to exist, but to dominate every ecological niche, to close feedback loops, to regulate atmospheric chemistry, to buffer against radiation impacts and climate drift. That kind of world wouldn't need to attack visitors. It would simply outlast them. And this is where the fear hinted at in the title begins to sharpen, because nothing in the James Webb data suggests active hostility. There are no lasers, no signals, no obvious technological signatures. What appears instead is something colder and more alien, indifference enforced by physics and biology. A planet that doesn't care if you survive. Consider radiation. Earth's magnetic field protects us from the solar wind, but it fluctuates. It weakens. It reverses. We've been lucky. Many planets are not. Yet some of these Earth-sized worlds. Webb is studying orbit stars that should strip atmospheres away over time, and yet the atmospheres remain. That implies either extraordinary coincidence or extraordinary protection. Magnetic fields don't just happen. They require active interiors, molten cores, energy transfer, long-term geological cycling. Those systems decay unless maintained by something. On Earth, plate tectonics help regulate carbon dioxide through the carbonate-silicate cycle. That process stabilizes temperature over geological time. Without it, Earth would have become either Venus or Mars long ago. Some exoplanets appear to have even tighter regulation. Not looser. That doesn't automatically mean intelligence. It doesn't even mean consciousness. But it does mean that whatever exists there has shaped its world so thoroughly that randomness has been squeezed out. And a system like that is not welcoming. It's optimized. The terrifying implication isn't that something is watching us. It's that nothing needs to. If humans ever reach such a planet, every step we took would destabilize an ecosystem that has no incentive to accommodate us. Our heat, our waste, our chemistry, even our breathing would be contamination. The planet wouldn't respond with aggression, it would respond with correction. In ecosystems, correction looks like collapse. Species introduced into balanced systems don't integrate. They trigger chain reactions, and chain reactions favor the system that's already established. The newcomer is the variable that gets eliminated. James Webb hasn't found monsters guarding Earth 3. It's found something worse. A reminder that life, when it succeeds, doesn't leave room. And as unsettling as that realization is, it's only the surface of the problem. Because the more we analyze these worlds, the clearer it becomes that habitability is not the same thing as accessibility. A planet can be alive without being kind. It can be stable without being safe. It can look perfect from light years away and still be utterly lethal to anything that didn't evolve there. And if that feels counterintuitive, it's because we're used to thinking of Earth as the baseline. But Earth is not a neutral reference point. It's the product of contingency, not inevitability. We survived here because we adapted to this chaos, not because chaos favors us universally. James Webb is showing us planets where chaos may have already lost. And that is a deeply unsettling thought. Because if Earth 3 exists, and all signs suggest that worlds like it do, then the question isn't whether we could ever reach it. The question is whether arriving would already be too late. But even that isn't the most disturbing implication hiding in the data. Because when you follow this line of reasoning all the way through, you're forced to confront something even darker about our place in the universe. And that's where everything starts to change. What makes this even more unsettling is that none of these conclusions require speculation about intelligence or technology. You don't need cities, machines, or signals to create a planet that quietly rejects outsiders. All you need is time, an absurd amount of uninterrupted time, and life that never had to compete with anything like us. On Earth, our biosphere is loud and messy because it's young. Complex life exploded only about 540 million years ago. Mammals rose to dominance less than 100 million years ago. Humans have existed for a geological blink. Our planet still carries scars from impacts, ice ages, volcanic catastrophes, and mass extinctions that reset the board over and over again. Stability here is borrowed, not owned. But many of the planets Webb is analyzing orbit stars far older and calmer than our Sun. Red dwarfs, in particular, burn for trillions of years. If life appears around them and survives early stellar tantrums, it could enjoy a stability window longer than the entire current age of the universe. That changes everything. Because life that has 10 billion years instead of 4 doesn't just adapt, it optimizes. It fills every niche. It eliminates inefficiencies. It closes loops that on Earth are still leaky and fragile. And in systems like that, there is no such thing as spare capacity. On Earth, oxygen buildup was catastrophic for early anaerobic life. The Great Oxidation Event wiped out most organisms alive at the time. From our perspective, that was progress. From theirs, it was an extinction-level disaster triggered by a new metabolic trick. Life didn't negotiate. It didn't slow down. It didn't care. Now imagine that process repeating for billions of years, refining itself again and again, until the planet becomes a tightly integrated biochemical machine. At that point, the atmosphere stops being just air. It becomes infrastructure. The soil stops being dirt. It becomes a network. The oceans stop being water. They become regulation systems. Anything foreign entering that environment doesn't arrive as a guest. It arrives as noise. This reframes one of the most comforting assumptions we've carried for decades, that life elsewhere would resemble early Earth, waiting to bloom the way ours once did. James Webb is suggesting that some worlds may instead resemble late-stage Earth pushed to an extreme, worlds where evolution has already played out its long game. And that creates a paradox. Because the more Earth-like a planet looks chemically, the more likely it is that it's already occupied by a system that has no tolerance for disruption. This is where fear creeps in, not cinematic fear, but existential fear. The kind that doesn't spike adrenaline but slowly rearranges how you think about the future. We've always assumed that the universe is hostile because it's empty, vacuum, radiation, cold, distance. But Webb hints at a different kind of hostility, environments that are hostile because they are complete. On Earth, ecosystems collapse when pushed too far. Coral reefs bleach, forests die, species vanish. But these collapses happen because our systems are still vulnerable, still flexible, still dependent on narrow margins. A mature biosphere may not collapse so easily. It may respond. Response doesn't require intention. It only requires feedback. Introduce heat, the system compensates. Introduce new chemistry, the system neutralizes it. Introduce organisms, the system absorbs or eradicates them. That's not defense in a military sense, it's homeostasis. And homeostasis is brutal to intruders. Think about our own bodies. We don't decide to kill bacteria. Our immune system simply reacts. Foreign cells are identified, isolated, and destroyed automatically. No malice, no awareness, just chemistry enforcing equilibrium. Now scale that up to planetary level. If a human landing party touched down on a world like this, every aspect of survival would be working against them. Not because the planet is dangerous in the obvious ways, storms, predators, toxins, but because nothing there evolved to coexist with something like us. Even microbial life would be incompatible. Our bacteria wouldn't recognize native chemistry. Native microbes might metabolize compounds essential to us. Oxygen itself, which we treat as a universal necessity, could be tightly regulated within a range that makes human physiology impossible. And this is where the idea of guardians stops being metaphorical. The planet doesn't need monsters. It doesn't need intelligence. Its very success is the barrier. James Webb's data is subtle, but its implications are relentless. It tells us which gases are present, how evenly they're mixed, how stable they are over time. When those patterns refuse to drift, refuse to decay, refuse to fluctuate the way lifeless systems do, something is maintaining them. Maintenance implies resilience. Resilience implies resistance to change. Resistance implies danger. What's especially haunting is that this danger would not announce itself until it was too late. From orbit, such a planet would look like paradise. Blue hues, temperate zones, possibly oceans, maybe even weather patterns reminiscent of home. The first explorers wouldn't be stepping into hell. They'd be stepping into something eerily calm. Calm is deceptive. On Earth, The most stable ecosystems are often the least forgiving. Old-growth forests don't recover quickly from disturbance. Coral reefs don't bounce back easily once broken. Ancient systems operate on timescales that do not accommodate rapid intrusion. And these exoplanets may be ancient beyond comprehension. Which brings us to the most unsettling layer of all, time asymmetry. We think of ourselves as early, as pioneers, as one of the first intelligent species to arise, but the universe doesn't owe us that status. Life could have appeared billions of years before Earth formed. If that happened, then some biospheres out there are not just older, they are finished. Finished evolving. Finished experimenting. Finished leaving room. That flips the script on exploration. Instead of searching for places to go, we may be discovering places we can never belong. And if that's true, then the real terror is that Earth 3 is guarded. It's that the universe may be full of worlds that are already complete. Worlds where arrival equals disruption. Worlds where disruption equals elimination. Worlds that don't need to attack, threaten, or warn. They simply persist. And persistence is the one thing we can't fight. Because the moment you realize this, another thought follows naturally, and it's even harder to shake. If such planets exist, and if James Webb is already finding candidates, then this isn't a future problem. It's a present one. We're already surrounded, not by enemies, but by ecosystems that never needed us. And that realization quietly forces a deeper question to the surface, one that has nothing to do with travel, technology, or ambition, and everything to do with whether humanity actually belongs anywhere else at all. And once that question is asked, it doesn't let go, but that's not all. If we go further and accept that some planets may already be complete systems, another assumption quietly collapses: the idea that intelligence is the final, dominant outcome of evolution. On Earth, we place intelligence on a pedestal because it worked for us. Tool use, language, abstraction, technology. These traits allowed one species to reshape an entire planet in a geological blink. From our perspective, intelligence looks like evolution's endgame. But James Webb forces a more uncomfortable possibility into view. Intelligence may be a phase, not a destination. Because intelligence is expensive. It burns energy, it destabilizes environments, it creates waste, heat, and rapid change. On Earth, intelligence didn't optimize the biosphere, it disrupted it. Forests vanished, atmospheres shifted, species collapsed. From a purely systemic point of view, humans are inefficient. A mature biosphere would not reward that. In fact, it might actively suppress it. Evolution does not aim for consciousness. It aims for persistence. Whatever survives longest with the least energy loss wins, and over billions of years, that logic becomes ruthless. Imagine a planet where life never took the intelligence detour, where evolution favored chemical efficiency over cognition, distributed networks over centralized brains, stability over innovation. Such a planet would not build cities. It would not transmit signals. It would not leave obvious artifacts in space. And yet it could be far more alive than Earth. James Webb can't see thoughts. It can't see tools. What it sees is balance. Gas ratios that shouldn't coexist unless something keeps them there. Temperatures that remain steady despite stellar fluctuations. Chemical cycles that refuse to drift toward entropy. That kind of order doesn't require intelligence. It requires time. This reframes the search for life in a way that's deeply unsettling. Because for decades, we've been listening for radio signals, laser pulses, megastructures, signs of minds like ours. But what if the most successful life never broadcasts? What if it has no incentive to? A biosphere that optimized itself long ago would see communication as noise, expansion as risk, curiosity as liability. It wouldn't look outward. It would fold inward. And in doing so, it would become invisible until someone else stumbled into it. That's where the terror sharpens. Because if such worlds exist, then Earth 3 isn't frightening because something intelligent is guarding it. It's frightening because nothing is, and that's worse. No warning, no negotiation, no hostility you can recognize. Just incompatibility. Human explorers would arrive carrying microbes evolved for Earth chemistry, digestive systems tuned for Earth biomes, immune systems designed for a specific microbial background. Even the act of breathing would be an intrusion. An intrusion in a closed system is an error condition. Think about what happens when invasive species enter stable ecosystems on Earth. They don't need to be malicious. They simply exploit niches faster than the system can respond. And the response, when it comes, is violent. Population crashes, toxin production, ecological collapse. Now reverse that. Humans would be the invasive species. Except this time, the ecosystem is older, faster, and far more tightly coupled than anything on Earth. Every metabolic pathway could be interconnected, every waste product recycled instantly, every foreign compound flagged chemically as wrong. We wouldn't be fighting predators. We'd be fighting chemistry. And chemistry doesn't negotiate. This also casts new light on why such planets might appear guarded in data, not by force fields or anomalies but by absence. No detectable industrial byproducts, no technosignatures, no pollution spikes, no orbital clutter. A planet that's been stable for billions of years would have already eliminated behaviors that threaten stability, including intelligence. That doesn't mean intelligence never arose there. It means it didn't last. Civilizations may have bloomed briefly, altered the system, and been absorbed back into it. Their materials broken down, their structures reclaimed, their impact erased not by catastrophe but by patience. Earth hasn't had time to do that yet. Our ruins last thousands of years. Our plastics last centuries. Our satellites will decay in decades. We mistake that for permanence. A billion-year-old biosphere would clean that up like dust. And that leads to a chilling reinterpretation of the so-called Great Silence. Maybe the universe isn't quiet because no one ever speaks. Maybe it's quiet because speaking is unsustainable. James Webb doesn't need to detect alien civilizations to suggest this. It only needs to show us planets that look too stable, too calm, too chemically disciplined. Worlds that have learned, through blind evolutionary pressure, that growth is dangerous, that novelty is risky, that complexity must be constrained. And suddenly, the idea of something guarding Earth 3 feels less like science fiction and more like inevitability. The guard isn't watching the sky. It's embedded everywhere. In the air, the ocean, the soil, the temperature gradients, the chemistry itself. A planet like that doesn't repel visitors by force. It lets them arrive. And then it waits, because time is the only weapon it needs. And once you realize that, another thought begins to form, one that's even more uncomfortable than hostile planets or alien intelligence. If such worlds are common, if stability beats intelligence in the long run, then our own future may already be written. Quite interesting, right? But that's just the tip of the iceberg. If you follow that line of reasoning far enough, the focus quietly shifts away from distant planets and back towards something much closer and far more uncomfortable, us. Because if James Webb is revealing worlds that appear stable precisely because they never allowed runaway intelligence to dominate, then Earth doesn't look like a success story anymore. It looks like an anomaly that hasn't resolved itself yet. Our planet is loud, chemically unstable, rapidly changing. We pump gases into the atmosphere faster than natural cycles can absorb them. We rearrange landscapes in centuries that took millions of years to form. From the outside, Earth would not look mature. It would look volatile. And volatility, in evolutionary terms, is a warning sign. The terrifying implication is that Earth may currently be in a temporary phase, one that other planets passed through long ago and survived only by closing it down. If intelligence really is a destabilizing force, then the long-term survival of a biosphere might depend on keeping it constrained, distributed, or rare. Not dominant, not planet-shaping, not exponential. That idea feels wrong to us because we sit at the center of our own story. But nature has no narrative loyalty. It selects outcomes, not protagonists. James Webb's observations suggest that some planets reached equilibrium without ever handing the steering wheel to a single species. Or, if they did, that species didn't stay in control for long. And that raises a brutal possibility. What if intelligence is not something ecosystems build toward, but something they learn to survive? On Earth, we often talk about runaway systems in climate science, feedback loops that accelerate change until something breaks. Ice melts, albedo drops, temperatures rise faster, leading to more melting. These loops don't care about intention. They're mechanical. Now imagine intelligence itself as a runaway system. Once a species can alter its environment faster than evolutionary correction can respond, it creates pressure. Pressure that doesn't disappear just because the species feels justified. On planets with shorter histories, that pressure might trigger collapse, mass extinctions, atmospheric shifts, sterilization events. On older planets, that same pressure may have been resolved earlier, either by eliminating the source or by forcing it into balance. Balance doesn't mean peace. It means limits. A biosphere that learned this lesson would not allow unchecked expansion, whether biological or technological. It would favor slow adaptation over rapid innovation, local optimization over global transformation. Which brings us back to the phrase that keeps haunting this entire discussion: guarded. The guard may not be an entity. It may be a rule written into the planet by billions of years of selection. Change too fast and you are removed. Disrupt cycles too deeply and you are absorbed. Refuse to integrate and you are erased. No malice required. And suddenly, Earth 3 stops being a destination and starts being a test we wouldn't pass. What makes this particularly disturbing is how well it aligns with something we already observe closer to home. Earth itself has reset dominant species many times. Dinosaurs ruled for over 160 million years. Then a single event, one rock, one moment, ended their dominance completely. Not because dinosaurs failed morally or strategically, because they were vulnerable to a system-level shock. From the planet's perspective, it was just rebalancing. Humans like to believe we're different because we're aware, because we can plan, because we can predict. But awareness doesn't grant immunity. If anything, it accelerates risk. Our intelligence lets us push systems to their breaking point faster than any previous species. And if planets elsewhere solve that problem by suppressing intelligence rather than celebrating it, then those planets may represent the universe's preferred outcome. James Webb doesn't say this explicitly. It doesn't need to. The data whispers it. Worlds with long-term stability leave signatures. Worlds in turmoil leave noise. We're noisy. And the more we learn about exoplanets that aren't, the harder it becomes to pretend that intelligence automatically equals success. This also reframes humanity's dream of becoming interstellar. We imagine spreading life, consciousness, culture, but a mature universe may not reward spread. It may reward containment. If that's true, then exploration itself becomes a dangerous act, not because of what we'll find, but because of what we'll introduce. Every human landing carries bacteria, heat, waste, entropy. On a tightly balanced world, that's contamination. Even careful exploration risks cascading effects, which leads to quietly horrifying realization. The reason we haven't been contacted. The reason no one has arrived. The reason the universe feels indifferent may not be because intelligent life is rare. It may be because intelligent life learns, eventually, not to interfere. And if that lesson spreads slowly but inevitably, then the universe isn't empty. It's restrained. James Webb is not showing us alien empires. It's showing us restraint made visible. And once that sinks in, the fear deepens again, because restraint implies memory. It implies that something happened often enough, long enough, for ecosystems across the galaxy to converge on the same solution. And convergence means pattern, which means what we're seeing may not be coincidence. It may be precedent. And if Earth is following the same path those worlds once walked, then the real question isn't whether Earth 3 is guarded. And once you accept that possibility, something else begins to feel off about the way we talk about habitable planets. We've been using the wrong word. When astronomers say a planet is habitable, what they really mean is that we could survive there. liquid water, mild temperatures, a stable star, an atmosphere we can tolerate. It's a deeply human definition, and it quietly assumes that the planet itself is incomplete without us. But the world's James Webb keeps hinting at don't look incomplete, they look finished. Their atmospheres are chemically calm. Their temperatures don't swing wildly. Their stars don't show signs of artificial manipulation. Nothing about them screams growth or expansion. Instead, they radiate endurance. And endurance is the opposite of what intelligence tends to produce. On Earth, every major leap in intelligence has been followed by instability. Fire reshaped ecosystems. Agriculture destabilized landscapes. Industry altered the atmosphere. Digital systems now reshape cognition itself. Each step brings power and fragility. From a planetary perspective, intelligence is not a stabilizing force. It's a stressor. Which means that a planet that appears perfectly habitable, but shows no signs of industrial disruption, may not be waiting for intelligence to arrive. It may have already learned how to prevent it from ever taking over. This is where the idea of a guardian becomes less poetic and more mechanical. Because nothing about this requires intent. All it requires is feedback. Imagine a planet where early intelligence begins to alter atmospheric chemistry, burning fuels, clearing forests, changing albedo. On Earth, those changes accelerate until they become dangerous. But imagine a planet whose chemistry responds differently. A world where small disruptions trigger large counter-responses. A rise in carbon dioxide that rapidly increases cloud cover, reflecting more sunlight and cooling the surface. A surge in methane that destabilizes biological niches, collapsing population growth. A shift in ocean chemistry that starves complex life of critical nutrients. None of this is speculative fantasy. These are mechanisms we already study in climate science. Earth simply happens to have buffers that delay the response. Other planets may not. On such worlds, intelligence wouldn't be eliminated directly. It would be discouraged. Growth would hit ceilings. Expansion would collapse. The planet wouldn't kill intelligence. It would refuse to support it beyond a certain point. And over geological time, that refusal would look like stability. Now zoom out. If that pattern repeats across enough worlds, it starts to shape the statistics James Webb is collecting. You don't see bustling civilizations. You see calm atmospheres. You don't detect industrial gases. You detect equilibrium. Not because life is rare, but because dominance is. This reframes one of the most unsettling questions in astronomy: why the universe appears so quiet. The silence may not be emptiness, it may be compliance. Compliance with planetary limits. And that idea carries an implication that's difficult to ignore. If planets naturally suppress intelligence beyond a threshold, then technological civilizations are inherently temporary. Not because they self-destruct dramatically, but because they are slowly smoothed out by the systems they inhabit. That smoothing doesn't leave ruins visible across interstellar space. It leaves atmospheres that look boring, oceans that cycle gently, surfaces that don't glow at night. It leaves planets that look exactly like the ones James Webb keeps showing us. Which means the terror is that Earth 3 is guarded. The terror is that Earth may be approaching the point where it begins to guard itself. We already see hints of this. Feedback loops accelerating faster than policy can respond. Systems interconnected so tightly that local disruptions become global crises. A species whose power increases faster than its coordination. From the planet's point of view, that's not intelligence, that's instability. And instability doesn't last. What's especially unsettling is that none of this requires extinction as a final act. The guard doesn't need to wipe intelligence out completely. It only needs to prevent it from remaining dominant. A sharp population collapse, a technological regression, a forced return to low-energy existence. Intelligence survives, but no longer reshapes the planet. That outcome would leave almost no detectable trace after a few thousand years. Which brings us back to the original question in a far darker light. What if Earth itself has already done this before? Not once, but multiple times. We talk about mass extinctions as random disasters, asteroids, volcanoes, climate shifts, but from a systems perspective, they are resets. Each one clears complexity, reduces dominance, and restores balance. The scary part is that intelligence hasn't arisen before us. It's that if it did, we wouldn't know. A prior civilization that burned for a few thousand years and collapsed would leave almost nothing detectable today. Plastics degrade, metals oxidize, structures erode, even nuclear signatures fade into background noise over millions of years. Geology is very good at erasing embarrassment, which makes James Webb's discoveries feel less like a window into alien worlds and more like a mirror held up to our own future. Those planets may not be empty. They may be post-ambition, and that interpretation changes how we should think about exploration. If intelligence triggers planetary defenses, not consciously but mechanically, then the act of arriving somewhere new isn't neutral. It's a disturbance. We imagine explorers stepping onto pristine ground, planting flags, starting fresh. But from the planet's perspective, that's the first symptom of instability. And the longer a world has existed, the more refined its response mechanisms may be. Which means the oldest, most stable planets are likely the least tolerant of disruption. The very worlds we consider perfect may be the most unforgiving. Suddenly, the idea of something guarding Earth 3 stops feeling dramatic and starts feeling inevitable. The guard may be chemistry, or climate, or biology, or simply time. And time, more than anything else, is merciless to systems that grow too fast. The deeper James Webb looks, the clearer this pattern becomes, not in words but in absence, in what isn't there, in the quiet consistency of worlds that refuse to spiral. And once you recognize that pattern, it becomes impossible not to wonder whether intelligence is meant to spread at all, or whether the universe quietly selects against it, one stable planet at a time. Because if survival favors balance over brilliance, then the most successful civilizations are the ones we will never see. And if that's true, if stability is favored over brilliance, then intelligence might not be the universe's end goal at all. It might be a side effect, a brief flare, something that appears when conditions line up just right and then fades once those same conditions are pushed too far. That idea feels uncomfortable because it runs against everything we assume about progress. We tell ourselves intelligence is the peak of evolution, that consciousness is the universe waking up and looking back at itself. But nature doesn't care about poetry. It cares about persistence. From a planetary perspective, a rainforest that lasts 50 million years is more successful than a species that invents radio and disappears in 5,000. And that brings us to a detail in James Webb's data that doesn't get much attention, but probably should. Many of these Earth-like planets don't just show signs of habitability, they show signs of age. Their stars are old, their systems are dynamically quiet, their atmospheres appear settled, not in flux. That matters because time changes the rules. On Earth, complexity rose quickly, but we're still early in the planet's life. Our atmosphere hasn't reached equilibrium yet. Our biosphere is still reactive. Our climate is still sensitive to disturbance. We are, in geological terms, a loud experiment in progress. Older worlds may not be so forgiving. As planets age, their systems tend to tighten. Feedback loops strengthen. Extremes are dampened. Anything that introduces rapid change is met with resistance, not adaptation. That resistance doesn't look like defense in the human sense. It looks like inevitability, which leads to a chilling possibility. Intelligence may be self-limiting not because it destroys itself dramatically, but because it eventually collides with planetary inertia. Think about how fragile modern civilization actually is. It relies on narrow temperature ranges, stable coastlines, predictable seasons, precise chemical balances. Small deviations cascade into systemic failure. Food systems wobble, infrastructure strains, societies fracture. Now imagine a planet where those deviations don't remain small. Imagine a world where atmospheric chemistry reacts sharply to industrial activity, where minor warming triggers massive cloud formation, where slight cooling locks oceans under ice, where biospheres are optimized for equilibrium, not expansion. On such a planet, intelligence wouldn't need an enemy. It would simply fail to scale. It might rise, build, experiment, and then stall. Generation after generation, growth would hit invisible ceilings. Technologies would plateau. Populations would stabilize or decline. The planet wouldn't punish intelligence, it would outlast it. And from the outside, that world would look calm. Which raises another unsettling thought. What if the universe doesn't reward civilizations that spread outward, but those that remain inward? What if the most advanced form of intelligence isn't expansionist, but restrained? We often imagine advanced civilizations as galaxy-spanning empires, but that image comes from our own psychology, not from physics or biology. Expansion feels natural to us because we evolved under scarcity. More territory meant survival. But a civilization that masters its environment completely doesn't need to expand. In fact, expansion becomes inefficient, risky, wasteful. If you can achieve long-term stability on one world, why gamble it on another? Interstellar travel isn't just difficult, it's destabilizing. It requires enormous energy, long time horizons, and coordination across generations. It introduces uncertainty into systems that may already be finely balanced. So perhaps the civilizations that survive longest are the ones that choose not to leave. And if that's the case, then the silence James Webb hints at isn't eerie. It's deliberate. Not because civilizations are hiding, but because they've learned that remaining quiet is safer than announcing themselves. Which reframes the idea of a guardian yet again. Maybe the guard isn't the planet. Maybe it's wisdom. A recognition that intelligence doesn't need to dominate to endure. That idea is unsettling because it puts us at a crossroads we don't like to acknowledge. Right now, humanity is behaving like an adolescent civilization. Rapid growth, increasing power, limited foresight, an obsession with expansion, Mars, asteroids, exoplanets, as if movement itself equals survival. But if the universe favors stability, then this phase doesn't last. Either we mature or we don't. And maturity in this context doesn't mean better rockets. It means restraint. It means learning how to exist without pushing systems past their breaking points. It means accepting limits, not as failure, but as design constraints. That's a hard lesson for a species built on the idea that limits exist to be broken. And yet, James Webb's discoveries quietly suggest that limits may be the rule, not the exception. The planets that endure aren't the ones that change rapidly. They're the ones that resist change. Which brings the fear closer to home. Because if Earth follows the same rules, and there's no reason to think it doesn't, then our future isn't defined by whether we can reach other worlds. It's defined by whether we can coexist with this one. The guardian may not be out there. It may be here. In the climate systems we're destabilizing, in the oceans absorbing our excess, in the biosphere quietly adjusting in ways that don't favor us. None of this is malicious. None of it is intentional. It's just physics, chemistry, and time doing what they always do, selecting for stability. And the uncomfortable truth is that intelligence doesn't automatically align with that selection. Which leads to a darker implication still. If intelligence is rare not because it's hard to evolve, but because it's hard to sustain, then the universe may be filled with worlds that briefly flared with awareness, and then settled back into silence. Not ruins, not artifacts, just planets that look fine. Healthy, stable, exactly like the ones James Webb keeps finding. That possibility changes how we should interpret discovery itself. When we find a planet that looks untouched, maybe it isn't because no one ever lived there. Maybe it's because the planet won. And if that's the case, then the question isn't whether Earth 3 is guarded. The question is whether any planet that lasts long enough eventually becomes one. And whether intelligence, as we practice it now, is compatible with that kind of longevity at all. Because if it isn't, then the greatest filter in the universe isn't war, or asteroids, or cosmic disasters. It's balance. And balance has no patience for ambition. Moreover, if balance is the real filter, quiet, patient, unavoidable, then the most frightening thing about these worlds isn't what they hide, but what they don't. No scars, no obvious ruins, no unmistakable fingerprints of intelligence. Just planets that look exactly the way a long-lived planet should look: calm, regulated, boring. That word boring is doing a lot of work here. Because from a cosmic perspective, boring is success. On Earth, every major extinction event wasn't caused by something trying to kill life. It was caused by imbalance, sudden shifts, volcanic winters, runaway warming, oxygen floods. Life didn't lose because it was weak. It lost because it pushed or was pushed past thresholds it couldn't stabilize in time. And yet after each reset, the planet recovered. Not quickly, not kindly, but eventually. Life returned because Earth systems allowed it to return. That distinction matters. Planets don't care which species survives. They care whether something survives. And the tools that help a species dominate, technology, energy extraction, rapid expansion, are often the same tools that destabilize the conditions that allowed that species to exist in the first place. So when James Webb shows us a planet with a smooth atmospheric profile, steady temperatures, and no obvious chemical chaos, that doesn't mean nothing interesting is happening. It may mean everything interesting already happened and was resolved. Which brings us to a hypothesis that sounds speculative until you sit with it long enough that it starts to feel inevitable. What if intelligence isn't rare? What if it's common but temporary? Across billions of years, across trillions of worlds, intelligence might arise again and again, not as a fluke but as a predictable outcome of complex ecosystems. Given enough time, some species will always start modeling reality, predicting outcomes, manipulating energy. But manipulation accelerates change. And acceleration is the enemy of equilibrium. So intelligence becomes a phase, a transient state between biological balance and planetary correction. Not because intelligence is evil, not because it's doomed by some cosmic rule, but because it introduces feedback loops that are too fast for planetary systems to absorb indefinitely. That idea reframes the Guardian in a deeply unsettling way. The Guardian isn't watching. It's waiting. Waiting for the moment when intelligence overreaches, and the planet's slower, heavier systems reassert control. That control doesn't look like annihilation. It looks like adaptation, but not in the way intelligence hopes for. Consider how subtle planetary corrections can be. A few degrees of warming, a shift in ocean circulation, slight changes in atmospheric composition. None of these end life, but they can end civilization. Civilizations need predictability. Agriculture needs seasons that behave. Infrastructure needs coastlines that stay put. Technology needs rare materials that remain accessible. Social stability needs surplus. Remove surplus, and complexity collapses. This is why the most dangerous changes aren't dramatic. They're gradual. They feel manageable until they are. And this is where the idea of an Earth 3 becomes especially disturbing. Because if such a planet exists, and the data increasingly suggests that many do, then it isn't just habitable, it's post-habitable. Not dead, not barren, but optimized. Optimized for endurance, not experimentation. On such a world, the margin for error would be razor thin. Any species that tried to industrialize would immediately run into environmental feedbacks. Population growth would plateau early. Energy use would be constrained by atmospheric response. Expansion would trigger self-correcting pressures. In other words, intelligence would be allowed, but only up to a point. Beyond that point, the planet would quietly reclaim control. This would feel from the inside like stagnation, a ceiling no technology can break through, progress that slows despite effort, systems that resist scaling. And eventually, culture would adapt. Values would shift away from growth and toward maintenance. Ambition would be redirected inward. Expansion would be seen not as destiny, but as danger. From the outside, such a civilization would be invisible. No megastructures, no galaxy-spanning signals, no loud technological signatures. Just a world quietly inhabited by a species that learned early on that survival depends on not being noticed. not even by their own planet. That possibility flips the usual narrative of cosmic loneliness. Maybe the universe isn't empty. Maybe it's quiet because silence works, which raises an uncomfortable mirror for us. Right now, humanity is broadcasting itself. Radio waves, atmospheric pollutants, orbital debris, heat signatures. We are noisy in every possible channel. If there is such a thing as a cosmic attention threshold, we crossed it decades ago. And yet nothing answers back. Not because no one is there, but perhaps because those who lasted learned not to reply. This isn't about fear of invasion. It's about recognition of instability. If you've watched civilizations rise and fall, your own or others, you may learn that contact introduces chaos, unpredictable variables, accelerated change. And if your entire survival strategy is based on equilibrium, chaos is unacceptable. So you don't reach out. You don't expand. You don't announce. You stay put. And you endure. James Webb can't see intent. It can't detect wisdom or restraint. It only sees outcomes. And the outcome it keeps hinting at is a universe filled with worlds that are not optimized for intelligence as we define it. They are optimized for continuity, which suggests something even more unsettling. Maybe the reason we keep searching for civilizations like ours and failing is because civilizations like ours don't last long enough to be found. We look for industrial atmospheres, radio leakage, heat excess, but those may be the signatures of a brief, unstable phase, cosmically short-lived. A flicker. If that's true, then the silence isn't mysterious. It's statistical. The window during which a civilization is detectable may be tiny compared to the lifespan of its planet. Miss that window, and all you see afterward is a world that looks fine. Alive, peaceful, guarded by nothing more than time. Which brings the question back to Earth, whether we want it there or not. If Earth is on the same trajectory, and all evidence suggests it is, then the real danger isn't some external force waiting to stop us. It's the assumption that there is no ceiling. That progress is always positive. That intelligence automatically deserves permanence. Planets don't operate on moral frameworks, they operate on feedback. And feedback doesn't negotiate. It responds. Slowly, relentlessly. The terrifying thing about Earth 3 isn't that it might be guarded by something unknown. It's that it might represent the end state of worlds that learned a lesson we're only beginning to confront. That survival isn't about conquering environments. It's about not provoking them. And if that lesson was learned elsewhere, learned deeply, permanently, then the universe may already be filled with survivors. They just don't look the way we expected. And yet, if restraint is the lesson these worlds embody, there's a deeper implication that quietly unsettles everything we think we know about intelligence itself. Because restraint doesn't emerge from ignorance. It emerges from memory. A species doesn't learn to stop expanding unless it has already experienced what happens when expansion goes too far. That suggests something profound. The calm planets James Webb hints at may not be pristine. They may be post-trauma worlds. Not scarred in obvious ways, not visibly broken, but shaped by histories long erased where intelligence once surged, reshaped the planet, and then encountered limits it couldn't bend. The planet survived, the civilization adapted or vanished, and the surface settled into a long, stable afterlife. On Earth, we underestimate how efficiently geology erases evidence. Entire mountain ranges disappear, oceans open and close, continents collide and dissolve. Even massive industrial footprints would vanish given enough time. Plastics break down, metals oxidize, cities crumble into sediment. After a few million years, the record becomes ambiguous. After a few 100 million, nearly invisible. Now stretch that across billions of years. A planet could host multiple intelligent epochs, each separated by planetary resets, so complete that even advanced telescopes would struggle to distinguish them from purely natural evolution. From afar, it would look like a quiet, mature world. Which means James Webb may not be observing planets before intelligence. It may be observing planets after intelligence learned its limits. That idea reframes the terrifying guardian again, not as a mechanism that blocks life, but as time itself acting as a filter. Intelligence that fails to integrate with planetary systems disappears. Intelligence that adapts becomes invisible. In that sense, the universe doesn't select for cleverness. It selects for patience. Consider how young our technological phase is. We've had industrial-scale energy use for barely 2 centuries. That's a blink compared to Earth's 4.5 billion-year history. In planetary terms, we are still a chemical experiment in progress. And like all experiments, there's no guarantee of success. James Webb's data shows us planets that have already passed through their volatile youth. Their atmospheres are stable. Their temperatures don't fluctuate wildly. Their chemical cycles are balanced. These are worlds that have settled into long-term equilibrium. That equilibrium doesn't happen by accident. It happens because feedback loops have already been tested, sometimes violently, and resolved. Now imagine being a civilization that survived such testing. You would learn quickly that growth has consequences, that large-scale energy extraction alters climate, that rapid population increases strain ecosystems, that altering one variable cascades into many. Eventually, you would stop asking how fast can we grow and start asking how long can we last. And once that question becomes central, everything changes. Technology becomes quieter, infrastructure becomes reversible, energy sources become constrained by environmental tolerance, not ambition. Culture shifts away from expansion myths and toward continuity myths. In that scenario, intelligence doesn't disappear. It folds inward. It stops advertising itself to the cosmos. And from the outside, there's nothing to see. This might explain a pattern that has quietly bothered astronomers for decades. When we search for extraterrestrial intelligence, we look for excess heat, excess radiation, excess structure. We look for signs of inefficiency at scale because inefficiency is loud. But longevity requires efficiency. And efficiency is silent. James Webb, unintentionally, may be teaching us that we've been searching for the wrong signatures all along. Not because we're foolish, but because our own civilization is still in its loud phase. We recognize noise because we make noise. We don't recognize silence because we haven't learned how to survive it yet. There's another unsettling layer to this. If planets enforce limits, and if civilizations that survive learn to live within them, then advanced intelligence might actually reduce its cosmic footprint over time, not expand it. That runs directly counter to nearly every science fiction narrative we've ever told ourselves. We imagine futures of spreading empires, galaxy-spanning networks, civilizations measured by how far they reach. But those are stories written by young species that haven't yet encountered planetary ceilings. Older civilizations might measure success differently. Not by expansion, but by persistence. Not by dominance, but by equilibrium. From that perspective, the most advanced worlds wouldn't be the ones reshaping galaxies. They'd be the ones that learned how not to. Which leads to a disturbing inversion. The absence of visible advanced civilizations may not mean intelligence fails. It may mean intelligence succeeds and then disappears from view. This makes the James Webb findings feel less like discovery and more like warning. Because Earth is not in equilibrium. Our atmosphere is changing faster than most natural processes can absorb. Our energy use is increasing exponentially. Our resource extraction assumes growth without end. We behave as though planetary systems are infinitely adjustable. They aren't. If Earth follows the same path as these distant worlds, then the guardian we fear isn't waiting somewhere out there. It's already here. It's the lag between cause and effect. Planetary systems respond slowly, but when they respond decisively. Climate doesn't negotiate. Oceans don't compromise. Feedback loops don't care about intention. They only care about balance. And balance doesn't require intelligence to understand it. It enforces itself regardless. Which means the most terrifying possibility isn't that James Webb found a world guarded by something hostile. It's that it found worlds that already won. and in doing so became indistinguishable from nature. Worlds where intelligence didn't vanish in fire or catastrophe. It simply learned when to stop. And if that's true, then the real question isn't whether Earth has a guardian. It's whether we're capable of becoming quiet enough to survive ours. Because once a planet finishes teaching that lesson, it doesn't repeat it loudly. It lets time do the rest. If intelligence learns to survive by becoming quiet, then there's an uncomfortable implication we haven't faced yet, one that sits right at the edge of what James Webb's data suggests, but never states outright. Silence may not just be the result of longevity. Silence may be the price of it. Because a civilization that truly integrates with its planet doesn't just change how it uses energy, it changes how it exists. And that transformation may be so radical that, from the outside, the civilization no longer looks like one at all. On Earth, intelligence is loud because it externalizes itself. We build, we burn, we broadcast. We leave marks everywhere, cities visible from orbit, atmospheric signatures detectable across space, waste layers that will persist in rock for millions of years. Our intelligence announces itself constantly because it depends on constant expansion to sustain itself. But expansion is a young strategy. Older systems tend to converge towards stability, not growth. Stars do this. Ecosystems do this. Planets do this. And if intelligence is a natural phenomenon, emerging from chemistry, physics, and time, then it too may follow that arc. Which means the guardian, hinted at by James Webb, may not be an external force at all. It may be the endpoint of intelligence. Think about what intelligence actually is. Not technology, not tools. Intelligence is the ability to model reality, predict outcomes, and adjust behavior accordingly. A truly advanced intelligence would not just understand physics, it would understand consequences. At some point, such an intelligence would realize that visible power is unstable. That large-scale manipulation of planetary systems introduces risks that compound faster than control mechanisms can adapt. That broadcasting one's presence invites interactions that cannot be undone. That expansion increases exposure. So instead of reaching outward, intelligence might begin collapsing inward. Not into isolation, but into efficiency. Energy use would plateau, not rise. Infrastructure would recycle itself perfectly, leaving no waste signals. Information processing would migrate into compact, low-energy forms. Biological bodies might give way to hybrid or entirely synthetic substrates optimized for minimal environmental impact. From orbit, such a world wouldn't glow with megastructures or industrial heat. It would look boringly alive. Forests cycling carbon, oceans exchanging heat, atmospheres breathing slowly. And beneath that calm surface, intelligence could persist indefinitely. Not as conquerors, as caretakers. That possibility reframes everything we think we know about detection. It suggests that the more advanced a civilization becomes, the harder it is to detect, not because it hides, but because it aligns so closely with planetary processes that it becomes indistinguishable from them. James Webb isn't blind. It's just honest. It shows us atmospheres that don't scream disturbance. It shows us climates that don't fluctuate wildly. It shows us chemical signatures that suggest regulation rather than exploitation. Those aren't signs of absence. They're signs of discipline. And discipline at cosmic timescales is rare. Which brings us to the most unsettling possibility of all. Earth may not be unique in hosting intelligence, but it may be unique in how recklessly visible that intelligence still is. Our planet has entered what could be called a planetary adolescence, a phase where intelligence has acquired immense power but not yet learned restraint. We extract energy faster than ecosystems can respond. We alter atmospheric chemistry without fully understanding feedbacks. We assume reversibility where none exists. From a distant telescope, Earth wouldn't look stable. It would look volatile. It would look like a world mid-experiment. And that's exactly the kind of world James Webb doesn't seem to be highlighting as common. Which raises an uncomfortable question. What happens to civilizations that never learn to quiet themselves? The geological record on Earth provides some hints. There have been moments when life reshaped the planet so dramatically that mass extinctions followed. Oxygen once poisoned most existing life. Volcanism reset ecosystems. Climate swings erased dominant species. In every case, the planet persisted. Life adapted or vanished. Intelligence would not be exempt from that rule. If a technological species pushes planetary systems beyond tolerance thresholds, the planet doesn't retaliate out of malice. It responds mechanically. Ice melts, currents shift, ecosystems collapse, habitable zones migrate faster than societies can follow. The result doesn't need to be dramatic. It just needs to be irreversible. And once a civilization collapses, the planet doesn't preserve its story. Cities erode, materials degrade, traces blur into geology. Given enough time, even nuclear signatures fade. After a few million years, the planet looks normal, stable, alive, which means James Webb could be observing not just quiet worlds, but recovering worlds. Planets that once hosted loud intelligence and outlasted it. That's the real terror lurking beneath the phrase Earth 3. Not that something guards these planets, but that the planets don't need guarding. They regulate themselves, and they do so over timescales intelligence struggles to compete with. There's another layer here that's even harder to confront. If advanced civilizations learn to quiet themselves, then interstellar contact may not be something they desire at all. Contact introduces unpredictability. It introduces cultural disruption. It introduces technological contamination. It introduces risk. A civilization that values longevity above all else would see contact as a liability. Not because others are dangerous, but because interaction is irreversible. Once you change another world, you can't undo it. Once you reveal yourself, you can't become unseen again. Well, the safest strategy isn't secrecy. It's irrelevance. Becoming so integrated with your planet that no external observer could distinguish intelligence from nature. From that perspective, the silence of the universe isn't eerie. It's intentional. Not intentional in the sense of a coordinated decision, but intentional in the sense that evolution favors behaviors that persist. Loud civilizations burn brightly and briefly. Quiet civilizations endure. James Webb doesn't show us the fireworks. It shows us the survivors. And that flips the emotional weight of discovery completely. Because suddenly, the terrifying thing guarding Earth-like worlds isn't a predator. It's a standard we haven't met yet. To survive long-term, intelligence may need to abandon some of the traits we currently celebrate most: growth, dominance, visibility, expansion. It may need to redefine success not as reaching the stars, but as remaining invisible to them. That's a hard pill for a young civilization to swallow. We tell ourselves stories where intelligence spreads endlessly, filling the cosmos with meaning. But those stories may be projections of our current phase, not predictions of maturity. A mature intelligence might see the universe not as territory to conquer, but as context to respect. And in that universe, the most advanced worlds wouldn't be the loudest. They'd be the quietest. Which brings the focus back home. If James Webb is showing us what stability looks like, then Earth's current trajectory stands in stark contrast. Our signatures are growing stronger, not weaker. Our impact is accelerating, not leveling off. Our systems assume that the planet will absorb whatever we throw at it. But planetary systems don't work that way. They have limits, and those limits don't negotiate. The terrifying realization isn't that something is guarding other Earth-like planets. It's that planets themselves act as filters. They allow intelligence to emerge. They allow it to grow. And then they test whether it can coexist with the systems that birthed it. If it can, it fades into stability. If it can't, it disappears, and the planet moves on. From that lens, James Webb's discoveries feel less like an announcement and more like a mirror. They show us what planets look like after the test, and force us to ask whether we're still taking it or already failing it. Because if intelligence really does survive by becoming quiet, then the most dangerous moment in a civilization's history isn't when it's weak. It's when it's powerful and still loud. If everything we've traced so far is even partially true, then the story James Webb is quietly telling us isn't about discovery at all. It's about timing, about where a civilization sits on a curve it doesn't yet understand. Because the most haunting possibility is that something terrifying is guarding Earth-like worlds. It's that we are looking at worlds that already passed through the phase we're in right now and survived it. When we imagine advanced civilizations, we picture inevitability, smarter machines, bigger structures, expansion across stars, progress as an arrow pointing outward. But nature doesn't work like arrows, it works like filters, pressures, narrow corridors that most things never pass through. Intelligence may be one of those corridors. Emerging is hard, surviving is harder, enduring is rare. James Webb doesn't see intention, it sees outcomes. And the outcomes it's showing us are planets that appear chemically calm, thermally balanced, atmospherically regulated, and astonishingly old. Worlds that didn't spiral into runaway greenhouse states. Worlds that didn't strip their atmospheres away. Worlds that didn't explode into irreversible chaos. That's not luck. That's selection. Somewhere between the first spark of intelligence and planetary-scale manipulation, something decisive must happen. A fork in the road that determines whether intelligence becomes a temporary anomaly or a permanent feature. And here's the unsettling part. That fork may not look dramatic at all. It may not be war or asteroids or alien invasion. It may look like comfort, stability, the assumption that systems will always recover. On Earth, our danger isn't ignorance anymore. It's familiarity. We understand enough physics, chemistry, and biology to know what we're doing, but not enough humility to stop when feedback loops start flashing warning signs. That's why this idea feels so disturbing, because it doesn't frame humanity as special victims or cosmic heroes. It frames us as participants in a pattern that likely played out countless times before. A planet gives rise to intelligence. Intelligence learns to extract energy. Extraction scales faster than understanding. Planetary systems respond mechanically. The window closes. What makes James Webb's data chilling is that it suggests some worlds avoided this outcome. Not by becoming louder, by becoming quieter, which forces a brutal reevaluation of what advanced even means. An advanced civilization may not build Dyson spheres. It may dismantle the need for them. It may not colonize planets. It may stabilize the one it has. It may not broadcast its existence. It may deliberately erase its signatures. Not because it fears others, but because it understands itself. At that stage, intelligence becomes less like a species and more like a process, embedded, distributed, self-regulating, not ruling the planet but co-evolving with it. From orbit, you wouldn't see cities. You'd see equilibrium. And equilibrium doesn't advertise. That reframes the fear in the title entirely. The terrifying thing guarding Earth-like worlds isn't an alien force. It's a requirement that intelligence must eventually learn restraint or vanish. Which brings us back to the most uncomfortable realization of all. James Webb isn't looking outward at them. It's reflecting something back at us. Because right now, Earth does not look like those worlds. It looks noisy, energetically uneven, rapidly changing, chemically destabilized. From a distant telescope, Earth would look young, reckless, brilliant, and unstable. Which means we're still early, still inside the dangerous window, still loud. And that may be the point where most civilizations fail, not because they lack technology, but because they never redefine success. If survival requires becoming invisible, then ambition itself becomes a liability. Expansion becomes a phase you grow out of. Growth becomes something you constrain. That's not a message humans like hearing. Our stories reward conquest, scale, dominance, speed. We celebrate civilizations that leave marks everywhere, but the universe may reward the opposite. Persistence, patience, restraint. James Webb doesn't confirm this hypothesis outright. It can't. Telescopes don't detect intentions. They detect consequences. And the consequences we're seeing suggest that the loudest civilizations don't last long enough to be seen. Only the quiet ones remain, which means the real horror isn't that something is watching Earth. It's that Earth itself may soon be forced to decide whether we belong among the survivors or the erased. Because planets don't need to hate intelligence to eliminate it. They only need to outlast it. And they always do. The universe isn't empty because life is rare. It may be empty because longevity is. And James Webb, silently and without drama, may have just shown us what longevity actually looks like. Not expansion, not dominance, but restraint so complete that it becomes indistinguishable from nature itself. If that's true, then the question isn't whether Earth 3 exists. The question is whether Earth 1 ever makes it there. And that is far more terrifying than anything hiding beneath another planet's surface.